All right, let's give you an example of how to find a sample size necessary, or how many in order to achieve a certain confidence level. And so as an example, we'll look at 7.1 number 34, and it has two parts in it, and both parts will show the different situations that can come up, because there's two different situations that can come up. So I have the problem typed out here, and it says a sociologist plans to conduct a survey to estimate the percentage of adults who believe in astrology. How many people must be surveyed if we want a confidence level of 99% and a margin of error of 4 percentage points? Assume that nothing is known about the percentage to be estimated, is what's written in part A. So as we look at part A, or just the question in general, we want to know how many people. So how many is the same as the sample size, and that's determined by n. So you'll be looking for an n formula, and you're going to go to the only formula, the one that was demonstrated in the last video, that has p's and q's in it. There will be another n formula when you come to take the test, because you've gone through 7.2, but that formula won't have any p's and q's in it. So let's take a look at what we can fill in. So in this situation, if we want to find n, z alpha over 2 is going to be linked to a stated level of confidence, and we have 99% confidence. So I'll write that over here. We already know from our previous experience, or at the bottom of that positive z-score chart at the bottom, that 99% confidence is linked to 2.575. So 2.575 is going to go in the bracket. We're going to square it. And then we're also, as we go across, p hat and q hat. Now those would come from a prior study, but A says that we don't know anything about the percentage. So when that happens, if there's no prior study, which we have in this case, then we're simply going to let p hat equal 0.5 and q hat equal 0.5. And I'll put that in right here, 0.5, 0.5. That's the biggest that product could ever be, and that's why we're using it. And then E should be related to a stated error. And so they talk about a margin of error at the very last part of the question itself, of 4 percentage points. So you want to be careful. You don't want to drop a 4 in there, because that's 400%. 4 percentage points is the same thing as 4%, and 4% is 0.04. And we need to square that as well. That's it. We just need to run those numbers. There is a rounding issue that we need to talk about, but let's take 2.575 and square it, multiply by 0.5 times 0.5, and divide by 0.04 squared. It's all one big happy multiplication family, and so we should be fine just plugging it in. And here's what we get: 1036.0351. So one of the reasons I picked this problem is because of exactly what happened there. N is a sample size, and this is the bare minimum sample size to achieve in order to be 99% confident that we're off by no more than 4 percentage points. So I have to be at this level or higher. But N is the number of people I need to talk to, so it doesn't make sense to talk to 0.035 of a person. And so we're always going to round N up, because 1036 is too small. It doesn't meet that threshold of 1036.035. So I call it the don't be lazy principle. Let's go talk to one more. So the answer for this problem is 1037 randomly selected adults would need to be seen. As we come in here, let me lower that. Oh, and let me hit paste. Whoops. Okay. So the part B to this lesson, I already typed out in here, or to this exercise is here. So let's go look at part B. So part B says, okay, now let's run the situation provided we had a prior study. And so it says, use the information from a previous Harris study in which 26% of the respondents said they believed in astrology. Okay, so the only difference here is we still want to be 99% confident. And so we're going to recognize that that tells us z alpha over 2 of 2.575 again. We still want to be a 4 percentage point margin of error. And so that's going to translate out to an error equaling 0.04. So that's all the same. So the only thing that's different as we run this formula with this part B is that we have a prior study. And so we're not going to use 0.5. We're going to use the 0.26 that they gave us and its corresponding value, 0.74, instead of the 0.5 because we have it, and then the 0.04. So as we look at the two formulas, right, if I can bring them both in, I barely can, you can see that the only difference is this product right here. If we don't know what the prior study is, then we use 0.5 like an A. But if we have a prior study, we'll always use it. And I apologize for this Z alpha over 2. I shouldn't have written Z alpha over 2 in there because we know what that is. For that Z alpha over 2, we know that that's 2.575. So let's run that number. That's 2.575 squared times 0.26 times 0.74 divided by 0.04 squared and hit equals, and you can see that we have to address way less. Now my number coming out is 797.33, but we're going to remember this is a sample size, so it's not possible to talk to 0.33 of a person, and we're going to go and talk to one more. Whoops, and look at 798 would be our answer.